Hello. Today we're going to do our Module 6 review for your test tomorrow. Your test will be tomorrow on Module 6. What I'd like for you to do is to take about 30 minutes to go through and do as much of this as you can on your own. So stop the video here or pause it, work on your own for about 30 minutes, and then come back to the video, please. Okay, for our first problem, we're going to graph this function, and we need to state our domain and range. Well, since it's a square root function, we know that it's a wave. It starts and it goes. So we need to make sure that we know our starting point. Our starting point is always the opposite of what's inside, and then whatever's added outside. So my starting point for this graph is going to be -6, -4. That's where I will start. Now because of my 2 here, I'm going to go up 2 and over 1, up 2 and over 3, up 2 and over 5, and that gives me my wave. So now my domain. Again, you can graph this in your graphing calculator and look for your go to y equals and type in your function and graph it, and you can look at the table of values to find what your graph looks like as well. My domain are my x values. Well, I start here at -6, and I'm going to the right, so I'm getting larger. So my domain is x is greater than or equal to my -6. -6 is my x value. My y value is -4 at this starting point, and I'm going up, so they're greater than also. Y is greater than or equal to -4. That is graphing our first one and stating our domain and range. Number 2. Again, I need to find my starting point. It's a square root, so I know it's going to be a wave. Opposite, which would be 3. And then what's added outside is nothing. So my starting point is going to be at 3, 0. Remember, go across to the 3 first, and then up and down for my second point. So 3, 0. Since this is a 1 here in front, and I'm going to go up 1 and over 1, up 1 and over 3, and it creates my wave. Again, I need to state my domain and my range. My domain are my x values. You'll see that I start here on the x-axis at 3, and I have values at 4, 5, 6, 7, and it keeps going. So x is greater than or equal to 3. My y values are my range. They start here at 0, and you can always tell that by your point. Starts here at 0 and it goes up to 1, 2, 3. As I keep going, this graph will continue to get higher. So y is greater than or equal to 0. Now problem number 3. Problem number 3 is a cubed root, so it's my wiggle. It does the little wiggle in the middle. And I have to find my point where it wiggles. That point is opposite, keep. So the opposite of inside is -5, keep is 0. So go across to -5 and stay there. Because this is a 1 here in front, I'm going up 1 and back 1, and I make my wiggle. Domain and range. The domain for a cubed root problem is all real numbers. The range for a cubed root problem is also all real numbers. I think we have one more graphing problem. The cubed root of the quantity x minus 2 minus 2. Well, I've got to find where that wiggle occurs. So opposite of what's inside and keep what's outside. So 2, negative 2. Put my dot. Now this is going to be where my graph is going to make its wiggle. That's where the wiggle occurs, since this is a 1 in each direction. Oh, that didn't need to come back up, sorry. There we go. Make that look a little better. Alright, so my domain and range for cubed root problems are both all real numbers. Alright, now we're going to move to the section of solving. If I have to solve my equation and check for extraneous solutions, I need to make sure that I get the radical by itself. I'm going to look at my problem. I see one radical. It needs to be by itself. So I'm going to divide both sides by 7. So I get the radical 12 minus m is equal to 2. Now I must get rid of this square root. The inverse operation for square root is to square it. So I will square both sides. 12 minus m is equal to 4. When I square a radical, a square root, it drops away. So my problem, I've still got to solve for m. So 12 minus m equals 4. I'm going to subtract my 12 from both sides. Negative m, please be careful of your negative sign right here, is equal to negative 8. Divide by negative 1, and m equals 8. Now I'm going to double check my problem. I'm going to plug back in to make certain that my problem works. 7 times the square root of 12 minus 8 needs to equal 14. Well, 12 minus 8 is 4. The square root of 4 is 2. 7 times 2 is 14. My problem does check, and this is my answer. Let's look at number 6. Again, I've got one radical. It needs to be by itself, so I need to subtract my 5. So I get the square root of 17x plus 2 equals 6. To get rid of the square root, I must square both sides. 17x plus 2 equals 36. When I square the radical, it drops away. So I have 17x plus 2 equals 36. There we go, sorry. Subtract my 2. 17x is equal to 34. Divide by 17, and x is 2. I come back in and I plug it in. 17 times 2 is 34, plus 2 is 36. The square root of 36 is 6. 5 plus 6 is indeed 11. It does check. That is my solution. I have one more where I have just a single radical. So this radical needs to be by itself. So I have to get rid of this minus 4. So I'm going to add 4 to both sides. So I get 6 is equal to the square root of 16 minus 2p. Because it's a square root, the inverse operation is to square. 36 is equal to 16 minus 2p, and I continue to solve my problem. I will subtract my 16. 20 is equal to negative 2p. Let me rewrite it over here. Kind of ran out of room. divide by my negative 2, and p is negative 10. If I plug my problem back in, 2 times negative 10 is positive 20. 20 plus 16 is 36. The square root of 36 is 6. 6 and negative 4 is indeed 2. My answer does check. Now number 8 looks a little different. It has 2 radicals. Well, I need my radicals to be on opposite sides, and they are in this problem, so I have to get rid of it. To get rid of this radical, I'm going to raise both sides to the same power. Since they are square roots, I'm going to square. I get 7 minus 2p is equal to 2p minus 1. I have variables on both sides of my equation, and so I must get rid of one of them. So I'm going to add 2p to both sides. 7 equals 4p minus 1. I'm going to add 1 to both sides. That gives me 8 is equal to, that cancels, 4p, divide by 4, and p is 2. 2. If I plug back in, 2 times 2 is 4, so 7 minus 4 would be the square root of 3. To this side. If I put in 2, 2 times 2 is 4. 4 minus 1 is also the square root of 3. Oops, sorry, you can't see what I just wrote. I apologize. I plug in the 2. 2 times 2 is 4, so I have 7 minus 4. Then I plug in the 2 here. 2 times 2 is 4, minus the 1. So I get square root of 3 is equal to square root of 3. That checks. That is indeed my answer. Number 9. Again, I have radicals on both sides, so I need to get rid of that. So to get rid of a square root, I'm going to square my problem. I get x plus 6 equals 12 minus x. Because I'm squaring a square root, they're inverses, they go away. I have x's on both sides, so I'm going to get rid of one of them. So I get 2x plus 6 equals 12. Be very careful. Realize that that's 1 plus 1. 1x and 1x is 2x. Subtract my 6. So I get 2x is equal to 6. Divide by 2. And x equals 3. I go back and plug in. I've got 3 plus 6. That's 9. The square root of 9 is 3. To the other side, I have the square root of 12 minus 3. That's 9. The square root of 9 is 3. That checks. My problem works. This is my correct answer. Now, number 10 and 11 are a different type of problem. I have one radical, but I have variables on both sides. To get rid of this radical, again, I will square both sides. That has been an ongoing theme throughout the entire set of problems. So I get negative 48 plus 14p is equal to p squared. Now, whenever I have a quadratic, a squared term, I need to make this equal to 0. So I'm going to subtract the 14p from both sides, and I'm going to add the 48. This all cancels, and I'm left with 0 is equal to p squared minus 14p plus 48. Now, here's where I've got to do a little thinking. I've got to figure out some numbers that will work to break down my middle term. I need something that's going to multiply to give me 48. Two numbers that multiply to give me 48, but they have to add up to negative 14.